Now, in some cases, you could have a capacitor and you're pumping positive charges up here, and this is just getting filled. It's getting too full, and so it's kind of over full at that point, and you can't put any more charges on it. If you put more charges on it, what will happen is you will get an arc from one side of the capacitor to the other, and you don't want to do that. That would break down the capacitor, and of course your purpose for storing charge up there, whatever that purpose may be, would be nullified. So, in order to be able to store more charge, one thing that we can do is we can put another capacitor here. And if you imagine a case where instead of starting with one capacitor that's fully charged up, we put a second capacitor. It doesn't matter if they're the same size or not, they're going to have the same kind of idea of what they want to look at here. The positive charges leave here, get to this point. It says, I'm just trying to get away from all the positive charges down here. Get up to this point, I might go here. Next one comes up here and gets to this point and says, well, I was trying to get away from these charges down here. There's a charge here, this doesn't have any, he's going to go up here. Next he's going to come up and go here. Next one will go up and go here. And they're going to charge up both of these capacitors in the same way that a single capacitor would be charged up, depending on what size they are. If they're the same size, they will get the same amount of charge. And of course, all the negative charges are going to run up here to cancel out. You know, as many negative charges as there are positive charges going to be up on that side. But what effectively we're able to do by putting the second capacitor in what is called a parallel structure. So when the charge gets up here, it has a choice of where to go. When you have a choice, that's a parallel structure. You can either go here or here. Basically, what we're able to do is to create two capacitors that serve as one big capacitor. They serve together. So when we have parallel capacitors, I'm just going to shorten that to caps. Okay? Parallel capacitors, the total capacitance, total amount of charges that we can store depends on the capacitance of number 1 and the capacitance of number 2. Just simply get added together. And if we had 3, it would be C1 plus C2 plus C3 plus C4 plus C5, however many that